So rectangles. Tell me what a rectangle is without looking up here.
A quadrilateral with 4 right angles on opposite sides.
Did you know that already, though?
Yeah.
Okay, so a quadrilateral, what makes it a rectangle is the fact that it has
Special type of parallel.
4 right angles, and it's a parallelogram. So what that means is that we have all the properties of a parallelogram, and then in addition to, it has 4 right angles. So obviously the opposite sides are congruent, and the opposite sides would be parallel as well. Parallelogram. That's really spelled wrong. Okay. There is one theorem that goes with this, and it specifically talks about the diagonals. If we have a rectangle, the diagonals are congruent. So we're going to kind of discover as to why here. So here's a rectangle. 4 right angles. Opposite sides are congruent. Okay, that's our first remark about rectangle here. Opposite sides are congruent. Opposite angles are congruent. Well, that should seem kind of obvious because all the angles are 90. Consecutive angles are supplementary. Remember, that's one of the properties of parallelograms. Does it make sense for a rectangle? Yep, the 2 angles next to each other certainly add to 180. Now, for a parallelogram, the diagonals here, they bisected each other, right? So for a parallelogram, these diagonals bisected each other. For a rectangle, they're not only bisecting each other, but they are also all congruent to each other. So we would mark these all with the same congruent marks. And the reason why, I'm just going to draw one of these out here. Let's see, 1, 1, 2, 1, 1, 2. These 2 triangles would definitely have to be congruent because of side, side, side. Okay. If we flip the diagonal around and drew it the other way, we still have these same exact triangles drawn again. So these 2 diagonals have to have the same length because they're all 4 congruent triangles. And then the other thing about rectangles are all 4 angles are right angles. So what's the really only new piece of information about this? You guys knew all 4 were right angles beforehand. Yeah, the diagonals are congruent and they bisect each other. That's a new piece of information about rectangles that you probably didn't come into this class knowing. Okay, so that's our new piece of information that we're going to have to add to our noggins. All right, so are we ready to try a few examples? Yes? Yes. Okay. RSTU is a rectangle. Find x. RT is 6x plus 4. SU is 7x minus 4. Why are these 2 equal to each other? Because the diagonals are congruent. So here we have RT. RT is 6x plus 4. And here we have SU, which is 7x minus 4. So we have the 2 lengths of the diagonals. We know the diagonals are congruent, so we can just make them equal to each other. And now we just have to solve this. So how do we solve this? Got minus the 6x and what else? Add the 4?
X equals 8.
Yeah, so x is 8. Is that okay? Ready for another example? LMNP is a rectangle. Find x and y. So now, on LMNP, we are given some angle measures. We are given that MNL is 6y plus 2. We are given that MLN is 5x plus 8. And we are given that NLP is 3x plus 2. So tell me some things you know about rectangles and their angles.
All 4 sides are 90.
Okay, so all the four angles are 90.
Wait, can you just put 5x plus 8 plus 3x plus 2 equal to 90 and then 6y plus 2 equal to 90?
Close. You had the first half of that right. So
6y plus 6y.
right now, we know that this is 90. So let's just solve for x. We can solve for x. Okay? So 5x plus 8 plus 3x plus 2 is equal to 90. So get your x's together. What do we have? 8x plus 10 is equal to 90 minus 10. So 8x is 80, so x is 10. Okay. Now, we only know one part of the angle up here. We only know M and L. Now, we only know that part. Do we know that those two pieces are equal to each other? So do we know that MNL and LNP, do we know anything about those two, like they're congruent? No, they're not. They're not the same. So instead, do we know that opposite sides are parallel?
Yes.
Is a diagonal a transversal?
So would it be 3x plus 2 again?
Yeah.
Okay, so could we solve for this angle measurement? This 3x plus 2? Okay. If I solve for 3x plus 2 by plugging in 10, what can you tell me about 6y plus 2? Yeah, it needs to equal that same angle because those are alternate interior. So, okay, so 3x plus 2, so 3 times 10 plus 2, so 32 degrees. Okay, so 32 degrees here, so what does 6y plus 2 have to equal then? That has to equal our 6y plus 2. So how would we solve that? Okay, so 30 is 6y.
5.
So y is 5. Okay, I only put the examples on here that would have been slightly different than the parallelograms because we've done quite a work with parallelograms. Okay, so these are the only ones that are different. Now, of course, you might have some diagrams where you know the opposite sides. You should set them equal to each other. Okay, but that's really, this is the new part of it. So your assignment is on page 428. You're doing 10 through 26, 33, and 52 to 58. Now, I'm trying to recall if there was a graphing one on this one or not, and I'm not sure. If there is a graphing one, we can regroup and talk about it, though. Okay.